next speaker is Dr. Ahmed Zayed. Dr. Ahmed Zayed is going to talk about waste water used in sanitary heating stations. Dr. Ahmed Zayed has got his university degrees and Bachelor of Civil Engineering from Cairo University. He holds an Environmental and Sanitary Engineering Diploma of Higher Studies from Cairo University, Master of Science from Cairo University, a Certified Consultant Doctor Engineer, Egyptian Syndicate of Professional Engineers from Cairo, and a PhD degree from Cairo University. Dr. Zayed has produced several papers and his professional scientific organization is member of several professional scientific organizations. He has been a keynote speaker in several conferences. So today he is going to talk about the floor is yours, 20 minutes.
Thank you, Chairman. Ladies and gentlemen, Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim wa ja'alna min al-ma'i kulli shay'in hayy. Our presentation topic today will be emphasizes on the unconventional water use, specifically for the domestic or municipal wastewater, which shall be categorized, and we will tackle the potential constraints which affect the quality of the water and the management plan required for the authorities or institutional or government who are follow up and also monitoring the source of the wastewater. Our main outlines in my presentation will be focused on 5 or 4 categories. We will make a comparative study between the guidelines such as World Health Organizations or Environmental Protection Agency under the USAID program implemented in Egypt, and also we will go as a case study in our Egyptian standards, and also will tackle how far the ground recharge will reach in such urban or industrial areas. And finally, we will conclude some of the recommendations shall be implemented in a management plan to be taken into consideration. First of all of us aware about the arid and semi-arid regions and the water scarcity and also the shortage in the water as a main source, even from fresh water or brackish water or desalinated water. And we are focusing on treated sewage or treated municipal wastewater and how the quality and how the management plan will produce such a technique to produce quality in compliance with the international standardization or with the local constraints such as the regional or country guidelines. Finally, we have to adopt or to recommend specific criteria will tackle the reuse or what's called water implementation in the agriculture and crops, or what's called in terminology as reclamation. First of all, the main categories in brief for the reuse of wastewater for the restricted or unrestricted irrigation, and most of the countries in GCC like Saudi Arabia or Sultanate of Oman differentiate between the type of water will touch the skin or the workers or the public, and this is under the restrictions, and also for unrestricted irrigation, which the water used for reclamation only tackle the workers and far away from the public considerations. Also, what type of the water shall be implemented in such aquifers or underground aquifers or as a barrier for stopping or to minimize or mitigate the intrusion of the seawater into the groundwater, and also environmental. And we will see here such a case studies, so many areas in Oman using the treated sewage effluent for recreation or for wetlands, or like for unsub ponds or other wetlands as environmental reuse. And also how far we can use the treated water or treated wastewater effluent in industrial for cooling, for makeup, or for recycling in such factories and such industrial areas, like we have seen so many cases in Egypt, and similarly we have so many cases in industrial area like Salah. Also, what is the indirect impacts to the potable water or to the source of drinking water, and how far the injection techniques or such implementation methods can affect the quality of the groundwater, and what is the meaning of the subsurface or surface augmentation. I will go through quickly what is the potential constraints for using the water specifically in the agriculture field. We have so many categories for wastewater use, but I will focus in agricultural irrigation and how far the water salinity and also like sodium absorption ratio can affect the permeability or the water infiltration in the soil voids, and also can impact the osmotic pressure or can affect the underground water source. And also from commercial wise, if we use the treated sewage effluent for plantation or for green areas, what is the marketing? What is the commercial? So some of the institutional or some of the governmental authorities should have a plan to make a good marketing wise for commercial use of the treated water. As we have seen here before, one of the colleagues presented that the cost of delivery of such treated wastewater effluent in Oman reaches about 0.2 Oman Riyal or 200 paisas. Also, what is the industrial recycling? Instead of using chillers or pulling water or recycling water, we should rely on the treated wastewater in industrial field, which can tackle 21% from the total usage, and to eliminate the shortage gap between the recycle of such desalinated water like in Sohar city or other areas. Also, what type of groundwater shall be recharged? Is it the treated sewage water quality after tertiary treatment or after secondary treatment? Is it industrial waste? If it is included to the sewage water and you have heavy metals like mercury or like other heavy metals substance traces, is it possible to inject this water to the recharging well or using other such barrier to prevent the intrusion of the seawater? Also, for the recreational environmental usage, we should be careful and be conservative to take into consideration if you are going to the park or recreation area, the spraying of the water can touch the skin if you have fecal coliforms or you have such biological contaminants can tackle and can making attack to the human body. Also, what is the non-urban use, like air conditioning or grey water using in the domestic plumbing, like toilet flushing. Also, we'll go to the guidelines, and the first guideline have been created in 1982 and adopted after for World Health Organization. They have differentiating between three major categories or three main categories. One is for crops you can eat, and one for the irrigation for such industrial food for animal food, or localized irrigation far away from the public intrusion or far away from the public conservation. And also we can have two main concerns in the water quality parameters, one for the nematode and one for the fecal coliform. As we know very well from biological and microbiology, the fecal coliform only used as an indicator, but the surrounding culture within the sample itself with the fecal coliform, this is our main concern, like viruses like protozoa and the other like Colisea. And what type of technique? Most of the techniques we are here studying in case studies in GCC, it is high-tech techniques, and also the cost of capex is very high, like you are using for activated sludges or other membrane bioreactors. But why you are not relying in such natural techniques? It was used in the past and it was successfully with OPEX and the monitoring plan like stabilization bonds. And what type of stabilization bonds, as indicated in World Health Organization guidelines for using a series of maturation bonds to infiltrate or to intrude the ultraviolet coming from the sun to kill all the viruses, and we will have a free of biological contamination in the wastewater without spending too much money for ozonation, chlorination, whatever the disinfection used. Also, for the USAID program have been implemented in Egypt such techniques for using the urban use like golf courses, like parks and others. We have to rely on the reclaimed water, and the quality of the water can be monitored via four major parameters, like the biological oxygen demand 5 days, it should be less than 10, and this cannot be achieved without using a high-tech and highly cost technique like filtration or what's called tertiary treatment. And for the fecal coliform should be non-detectable, and this can be achieved by a dosage of chlorine reached 5 ppm or 5 milligram per liter, or using ozonation or using other techniques for killing the microorganisms. And most of the treated wastewater effluent plants also recommended to have a residual chlorine not less than 1 ppm as the direct customer connection, and this can be achieved by dosing in the main source in the upstream before discharging the wastewater to the network by 5 or 6 milligram for chlorine or free chlorine dissipation in the contact time to kill the microorganisms. Also, what type of agriculture you use? Is it used for food crops or for commercial or non-food crops? And that time we can reduce the quality or increase the contamination levels and reach from the tertiary treatment to less economic solution like secondary treatment or biological treatment only. In that case, the BOD or COD will reach within the 20 or 50 milligram per liter or ppm. And also, of course, the residual chlorine should be in the water within the level of 1 milligram per liter. Also, if we'll take a case study of our Egyptian water resources, as we know that we are here in the semi-arid or arid countries, God gives us the Nile River, and the quantity per year can be reached as per the Ministry of Water Resources and Irrigation about 56.8. Precipitation we have 1.8 billion cubic meter per year, and also groundwater extraction in some areas like in northern or deserts around 1 billion cubic meter per day, and for specific area like Tunisian area like Sharm or Daga or Red Sea, we are desalinated the seawater which can reach 0.1, and the total water resource quantity we can summarize approximately 559.7 billion cubic meter per year. As a wastewater index or indicator, we are using only wastewater use for agriculture 2.9, and we are discharging most of those quantities to the valleys or valleys or to the sea or to the Nile River itself. And the reuse in such dilution or mixing of the agriculture drains with the canals of irrigation drain, it reached about 7.5 billion cubic meter. And as adopted regulation, specifically compared with the WHO or compared with the Environmental Protection Agency in the States, we can see in Egypt we have 3 classifications. The first priority for the first classification of the wastewater treatment is rely on reducing the BOD as a main factor for